the monsoon itself came early, both to the Bay of Bengal, then to Kerala, and it covered the entire country much earlier than normal. So, but this time there have been 19 western disturbances between June and September 7th, June 1st and September 7th, which was extremely high. The Western Himalayas, the Eastern Himalayas, all of them are extremely vulnerable to landslides, and there are certain regions where construction should not actually take place. There's so many other instruments that IMB needs to get and needs to install to basically make its observational system robust. We are taking steps. India is taking steps. India has cut down emissions in a lot of sectors, but more needs to be done because India is also a big economy.
Okay, thanks a lot, Akshit, for joining us for this talk and giving us the opportunity to discuss the what I would call the climate fiasco happening all around us right now. So I would start with the fact that the summers in the rainy season in India have been, especially in the northern India, have been very intense this year. And especially if you see the monsoon, it has been very uh, disastrous and it has been deadly for many people. So, I mean, how do you read this? What are the reasons behind it?
So there are quite a few reasons for why the monsoons have been so active this year. So one is the monsoon system itself was pretty active. Monsoon trough basically establishes itself over northern India, northern plains around June, and there's another offshore trough that establishes itself from around Gujarat to Kerala, the coast. Basically, which gives a lot of rainfall to the Western Ghats. So these are the two main monsoon systems. But apart from that, there are a lot of cyclonic circulations that occur. There's a lot of low pressure areas that form both in the Bay of Bengal and in the Arabian Sea. And then there are a lot of other smaller storm systems that also form along with these main monsoon systems, which cause rainfall. So all of these systems have been active during the current monsoon season. In fact, the monsoon itself came early, both to the Bay of Bengal, then to Kerala, and it covered the entire country much earlier than normal. By I think around June 29th, the monsoon had covered the entire country against a normal date of around July 8th. One was that the active monsoon conditions, but there were also some things that were new during this current monsoon season, and these were these western disturbances. Which formed throughout the monsoon season, and then there were also these anomalous winds that were there from the Arabian Sea. So these new weather systems also kind of added to the moisture over India, and then also to the precipitation that happened all along India. The western disturbances mostly were active in the northwest part of India. That is why northern India faced such devastating floods. And then the Arabian sea winds also added to that. Along with this, the number of low pressure areas also was higher than normal. In fact, throughout the monsoon season from June to September, there were 69 low pressure days when low pressures were active against a normal of 55 days. In September itself, there were around 23 days of low pressures instead of the normal of 12, which is double the normal amount. So these were the major systems. But apart from that, monsoon itself is impacted by warming in general. The background warming that is happening due to the emissions of greenhouse gases, that itself is affecting the monsoon, and it is affecting the monsoon mainly by adding water vapor, moisture to the system, because with every 1 degree Celsius of warming, around 7%. There's a 7% increase in water vapor in the atmosphere, and that itself basically also causes extreme rainfall events that we have seen all through the season.
Right, Akshit. So I would go back to a very good piece that you wrote for Down to Earth, and I really liked the title, "Melted Like Wax," because I mean, one, I would also want to know why did you title it "Melted Like Wax," and second, I mean, if we look at the Himalayan regions, they have been very badly hit. All of a suddenly, you see a cloud burst, and the entire village disappears. So, what are the reasons behind that? Because I mean, yes, these disturbances have been happening very frequently, but it's not that they're new.
Yeah. The title was completely an editorial call. I had nothing to do with that. But I can give you the circumstances why such a title was given. It was because when we were looking at the floods, the way that it was happening, and it was like an everyday affair. Every hour, every day, there was something that was happening all through the mountainous regions. This was Ladakh. This was Jammu Kashmir, this was Himachal, Uttarakhand. We were looking at things in like towards the end. Also, Sikkim and North Bengal happened. Not just the floods that happened in September, but also before that there were some flooding that had happened in July and August in that region. So overall, we kind of had a sense that this is something that is unprecedented in a way. It was not just the monsoon, the weather systems that were like that. There were new that were not studied very well and all of that, but also the kind of construction that has happened on the slopes. So both these, so there were a multitude of factors which basically were involved, and all of that basically melted like wax. That is what the title basically says. With why this has happened, there's a lot of factors in that. I'll talk about the meteorological factors first. There was a confluence, as I already talked about. There were some new systems or new things that were happening in the monsoon this year, and one of the primary things was the occurrence of western disturbances. So western disturbances are basically extratropical storms. They occur in the middle to upper layers of the atmosphere, and they trigger cyclonic systems more towards the surface, and then that causes rainfall. And western disturbances are mostly active during the winter and spring months for us. They usually form around the Mediterranean Sea, the Caspian Sea, the Black Sea areas, and then also the Zagros Mountains in Iran. So that is the region where these systems form in the upper layers of the atmosphere, and then they travel over Iran, Afghanistan, Pakistan, and then start affecting the Himalayas. They bring most of the snowfall for the Western Himalayas, and then they also cause rainfall in the plains of Northwest India, North India, and even in Central India during winter and spring months. All of that winter rainfall, winter precipitation happens because of these western disturbances. So, climate scientists know that around 4 to 6 intense western disturbances affect India during those months from December to March. These western disturbances are brought in by a wind system known as the subtropical jet stream, subtropical westerly jet stream. And this jet stream is basically a band of winds around the planet. And there are different kinds of jet streams. There's a subtropical jet stream, there's an Arctic jet stream, there's an Antarctic jet stream. So there are different layers, different latitudes, there are different kinds of jet streams in the uppermost layer of the atmosphere. And these basically bring these western disturbances from that region to India. And towards the late summer and early monsoon, this subtropical westerly jet stream basically moves northward. And once it moves northward, then the southwest monsoon sets in India. And this is a system that has been there for like thousands of years, maybe even millions of years. So, and this is a system that is very stable, that occurs every year. Periodically, it occurs every year. But now there are changes to this system. And these changes are due to changing climatic patterns. And most of it is associated with the warming of the Arctic. The Arctic region is warming at a rate much faster than the rest of the world. Some papers say it is, scientists are not really sure also at what rate it is happening, because some people say it is twice, some people say it is thrice the rate, some people say it's 4 times the rate. There are certain regions within the Arctic which are actually warming. There are papers which say that it is warming at 7 times the rate as the rest of the world. So that warming is associated with these western disturbances, and I'll explain how that is happening. So this northward movement of subtropical westerly jet stream is not happening in time. It is getting delayed, and that is basically because the warming of the Arctic is causing the gradient between the Arctic and the equator to decrease. And because this gradient of temperature is decreasing, that is why the northward movement is not happening on time. And this is basically leading to the western disturbances being active even during the early part of the monsoon, that is basically June. But still, like for instance, the 2013 floods in Uttarakhand, which basically that where 5,000 more than 5,000 people died. That happened because of a western disturbance active during that time, and the monsoon system also being active at the same time. So that happens. But generally, there are around two western disturbances in June, maximum, I'm saying. And the rest of the months, July and August, there are one maximum, and in September, there literally none. So, but this time there have been 19 western disturbances between June and September 7th, June 1st and September 7th, which was extremely high. And so this was data that was analyzed by Down to Earth, and then it was also corroborated by climate scientists from University of Reading and IIT Bombay, and we found this. And that is how the story of melted like wax happened. We found that this is happening, and then one of the scientists told me that most of these western disturbances are not originating over the Mediterranean; they are originating over North Pakistan and North Afghanistan. Which was surprising because usually Western disturbances are originated there. But then another scientist had a hypothesis that these Western disturbances are not really the classical Western disturbances, but there are a different type of Western disturbance which appears or in shape and in every other way like a Western disturbance, but it is not actually the classical one. It's a different type, and so this is less studied. There are only around 10% of the total number of Western disturbances that are like this, that are formed like this. They are known as potential vorticity cutoff lows. Okay. And they don't originate over the Mediterranean, and they don't originate over the subtropical jet stream. They originate in the Arctic region, and they basically get cut off from the Arctic jet stream, and then they come southward to lower latitudes, and then they start appearing over North Afghanistan, North Pakistan region as Western disturbances. But this is just a hypothesis. Kiran Hunt from University of Reading is doing research on this, but this was a hypothesis that he gave us, and that is why we wrote about it. So these could explain the Western disturbances that have been active in the monsoon season this year, and the numbers as well, because the warming of the Arctic is making the Arctic jet stream wobblier. It's making it unstable, and because of that, there might be more number of cutoff lows that are originating from there. But this is again a hypothesis; it's an active area of research. So this was one part of it, and then there is also the Arabian Sea winds, the anomalous winds from the Arabian Sea, which have been active this season. And what they have been doing is all the low pressure areas that were forming in the Bay of Bengal, they kept pushing them towards Northwest India. So there was basically the moisture coming from the Arabian Sea winds, there was the western disturbances, there was the low pressures coming from the Bay of Bengal. All of this added to the moisture over Northwest India, which caused such catastrophic rainfall, and then catastrophic floods and landslides that happened in the mountainous states, and then the riverine floods in Punjab.
That's one part of it, but you've been continuously telling about how climate change is impacting these things. We also tend to forget that there are also infrastructural lapses that are happening on part of successive governments. I mean, if you look at Himachal, it's happening almost every year now. And the famous photo that they show is of Chandigarh-Manali highway being submerged again and again. And the next year it repeats, right? The soil beneath these mountains is moving very fast. What are other such similar reasons? I mean, right now we see Jharkhand has seen more than 400 deaths after floods.
So one very good point that you make is about soil moisture. Definitely, the soil is saturated, basically, because year after year for the last 3-4 years we've been seeing floods. We've been seeing excessive rainfall in these regions, and because of that, the soil is completely saturated, and the mountains have become unstable. And it is not just that they have become unstable now. Himalayas are a very young mountain range. They are already very prone to landslides all through the Western Himalayas, the Eastern Himalayas. All of them are extremely vulnerable to landslides, and there are certain regions where construction should not actually take place. There are zones within the Himalayas where there should be actually no construction at all, because they're extremely vulnerable to such events.
And the continuous deforestation that is happening along with it.
Exactly. In fact, there were videos that showed that there was a lot of logs that had come in with the debris in Himachal Pradesh, in Jammu Kashmir, and all those regions. It shows that deforestation is happening all over the hill slopes, and those hill slopes are basically stabilized by those trees. If you cut down the trees, then the little bit of resistance that is there for the flowing water, that isn't there, and both the topsoil and the trees.
It gets a smooth flow into the valley wherever it is.
Exactly, and that is the exact reason for the floods in Kerala as well. The Western Ghats also are there's a lot of deforestation happening. There's a lot of construction that is happening, and so all these factors together with the changing climate. So basically, climate change becomes, and the factors around climate change and the changes in weather systems becomes an added factor. It's an exacerbating factor. So, and it becomes a compounded event, basically.
But actually, there's also another angle to it, which people rarely talk about it, is that because of this massive climate change and these incidents happening in the Himalayan region, there's also massive migration happening, right? And it's also impacting economic activities of the people there, because most of these areas rely on tourism as one of their primary source of earning. How is that getting impacted? Because people are now moving to cities which are, you'll have villages in Uttarakhand which have been left vacant for years now.
Yes, there are many villages. There are many ghost villages in Uttarakhand. We keep talking about ghost cities in China. There are ghost villages in Uttarakhand where there is no one there, because everybody has gone to other places where which are less vulnerable to such events. And this migration will increase. In fact, at some point of time, the government has to take steps for planned relocation of many of these regions. So the adaptation strategy has to move to the level where we kind of do zonation and risk assessment for all these areas, and then designate certain areas as no-go areas or no building areas, and then even relocate the people from there, because otherwise they will always be living under very, very high risk. And so from the kind of migration that is happening, which is voluntary and forced in a way, in fact, the government has to look at doing it in a very planned and organized manner.
You've been saying that since these are new things which are happening and these disturbances are still being studied, would it be wrong to say that our early warning system and the infrastructure that we have around assessing whether what is going to happen or not, we're not very well equipped in that, and we need to make it over again?
Yes, because any early warning system of any kind completely depends upon, first and foremost, depends upon the forecasting. If the forecasting is correct, it's exact, it's accurate, only then the rest of the system can work. So currently India is taking steps. I'm not saying that it is not. There's a new forecasting system in place. It's known as the Bharat forecasting system. It was launched just earlier this year, and it was in the works for around more than 2 decades. And it is now in place. In fact, what it does is it reduces the resolution of the model. The earlier model that we were using, the weather forecasting model, was 12 kilometer by 12 kilometer resolution. It has now brought it down to 6 kilometer by 6 kilometer. In fact, the scientist who primarily worked on this, whose brainchild Bharat forecasting system is, Sarthi Mukhopadhyay, he basically says that the model can even work at 1 kilometer by 1 kilometer resolution. But you need observational data for that. That is the second most important thing for forecasts or any models, whether it is climate models of long-term climate models, or whether it is day-to-day forecasting models or mid-range models. All of them need observational data, and that India is still lacking, especially in areas such as the mountains, the hills. The observational data network is still not there, still not good enough. Also with the oceans, the observational data is not good enough. In the case of the oceans, studying low pressure systems, studying tropical cyclones, tracking them, giving early warning for those. In the mountains, things like cloudbursts, giving early warning for cloudbursts are still not. AMD is not able to do that because observation data in the mountains is not available. Especially, there are instruments known as the Doppler weather radars. These basically study the winds and the moisture and the rainfall in a very minute on a very minute scale, and you require Doppler weather radars to be present all through the mountains to be able to do this. But they are not there. There are, I think, three Doppler weather radars throughout Uttarakhand. There are a couple in Himachal Pradesh and like that. But you need to increase the density of these Doppler weather radars. There's so many other instruments that IMB needs to get and needs to install to basically make its observational system robust. Once the observational system is robust and the forecasting system which is already in place that can work, then after that the rest of the system where you do communication between the IMD and then also the other state departments and then the implementation agencies on the ground. So last mile outreach, last mile communication to the people who are to be evacuated, who need to be alerted, still is not in place.
Right. So, Akshit, just picking up from that point, you say last mile. I mean, just a food for thought. What if we introduce a topic like climate change in the school curriculum? I mean, because we also need to teach our future generations on what they're going to face.
Yeah, exactly. It should be done. It should already have been done. I don't know. I've not gone through school textbooks recently, but I don't know how much of climate change is actually taught to students. CSE has a program of introducing climate change to schools and to teachers. In fact, I recently had a session with school teachers from various schools around North India, around country, and but these were like smaller groups. But this needs to be done by the government, and it needs to be done on a scale that is, much larger.
My last question, and it's much more a broader question, that it's also not just about one country, right? The South Asia and what we call the global South. We're not the largest emitter of carbons. There are bigger economies emitting more carbon than us. But the net zero goal and all that being there in mind, and since COP30 is coming, what should be India's strategy vis-a-vis cutting down emission rates and all? Because with coming in of carbon credits and everything else, the richer will get more and more benefit to pollute as much as they can, while the countries like ours will suffer, right?
In fact, per capita consumption in India is still very low. If you compare it to countries like China, US, any of the other Western countries, even the European countries, our per capita emissions are still very low. And because we are a growing country, we need to pull a lot of our population out of poverty, and we need to develop. So that is, and our plans to cut emissions are on track. The COP, the UNFCCC, also says that India's cutting of emissions is on track, and we are taking steps. India is taking steps. India has cut down emissions in a lot of sectors, but more needs to be done, because India is also a big economy, is also a large economy which has a lot of responsibility towards the world. That also needs to happen. But then there's also a lot of pressure that needs to be built on the largest emitters, on US, on Europe, on the UK. All these countries, all these regions need to step up their payment to the what was promised under the Paris Agreement, which has not come true. Even last year, we saw at COP29 in Baku that those promises are still being delayed, are still being under the garb of negotiations, under the garb of climate talks. No progress is being done. Whether it is on mitigation, whether it is on adaptation, whether it is on loss and damage money, all of those things that are the responsibility of the biggest emitters, the historical emitters of greenhouse gases, they're still not coming to terms with that. They're still not up to the task, and more pressure needs to be built. That because they are not the ones who are going to sit back and watch. Europe is warming at a rate much faster than the rest of the world. It's already crossed 1.3. So
and also we need to draw links between the climate change and health. How climate change is now massively impacting health of various people. You can't go outside and run because the PM level is so high that various factors related to it.
Humid heat waves is one of the greatest concerns all across the world, because the levels of moisture, as I've told you, like with every 1 degree Celsius temperature rise, there is moisture added to the 7% moisture added to the atmosphere. This moisture is not just acting on precipitation levels. It's not just causing tropical cyclones to become more intense, but it is also causing humid heat waves, which was not the case earlier. In fact, IMD brought out the term warm and humid days, or started giving alerts for that since last year.
Because the temperature is 39 and it feels like 51.
Exactly.
And we don't have the concept of feels like.
Yes, exactly. It was not there earlier because there was not so much moisture, so much water vapor in the atmosphere to be able to impact the temperatures, and they impacted a lot. And you can't run, as you said, like when you go out, you can't run because of air pollution. You can also not run because of humid heat. Early in the morning at 7 or 8, your temperatures feel like in the 40s. So how can you go out and run? So all these things also, people need to be made aware that climate change is not just affecting somewhere in the hills or somewhere in the mountains or somewhere in Arctic or Antarctica. It's impacting them in their daily life and their daily health. And this needs to be put out to people. And obviously, the best way to do it is in schools and colleges.
Thank you so much, Akshit, for talking to us. Thank you so much.
Thank you, Pranjal. Yeah.